Hello students, in this video we'll take a look at scientific notation. A number is written in scientific notation when it is expressed in the form a times 10 to the nth power, where a is a number whose absolute value is greater than or equal to 1 and less than 10. That is, it's a single digit number, okay? Single digit in the whole number place, okay, or integer valued place, that is. And n is an integer. Okay, let's look at some examples and compare standard form, that is without exponents, to scientific notation form. The number 12,600,000, okay, if we put that decimal point right here, we can write that as a 1.26 times 10 to the 7th power. Okay, so scientific notation has a number, okay, with an absolute value again that's greater than or equal to 1 but less than 10. So you're only going to see a single digit here to the left of that decimal point. Okay, and then we just count the number of places. 0.00027. Okay, we're going to move that decimal point 4 places and write this as 2.7, in this case, times 10 to the negative 4th power. Okay, this is a very small number, isn't it? And 10 to the negative 4th power is a very small number. Maybe we need to recap 10 to some powers here, okay? 10 to the 3rd power is 1,000, isn't it? And 10 squared is 100, and 10 to the 1st is 10. And we remember that 10 to the 0 is 1. Okay, and continuing like fashion, 10 to the negative 1 is 1/10 or 0.1. 10 to the negative 2 is 1/100th or a 0.01, and 10 to the negative 3 is a 1,000th or a 0.001, and so on, okay? 10 to the negative 4, let's just go one more step here, okay, is a 0.0001. So notice there are 4 decimal places there in that number, okay? So anytime we use a negative exponent with 10 as a base, okay, we're dealing with a very small number. As we look at our third example in our table, this is a very small number, and in absolute value that is, and it's negative, isn't it? Now we're going to want to move this decimal point 1, 2, 3, 4, 5 places. The number remains negative. 3.41 times 10 to the negative 5th power. And now let's try this process in reverse. If we look at a number in scientific notation form, 8.7 times 10 to the 5th, okay, this is going to be a large number. We're going to move that decimal point 5 places to the right. Okay, so our decimal point was here between the 8 and the 7, and as we move that 5 places to the right, in standard form we have 870,000. Lastly, we've got a negative number, negative 3.28 times 10 to the negative 6th power. So we know over here it's going to be a negative number as well. Okay, it's going to be a very small number in absolute value. As we move that decimal point, let me erase that there, okay. So we move that decimal point 6 places to the left. Okay, it was right here between the 3 and the 2. 1, 2, 3, 4, 5, 6, and decimal point, and I'm going to just slip a leading 0 in there in the front. Let's just check this again. 1, 2, 3, 4, 5, 6. Yep, we've got 5 zeros there. Then our 3 to 8, and that's our standard form without exponents. Let's look at a couple of applications using scientific notation. In example 1, the body of a 150-pound person contains 2.3 times 10 to the negative 4th pounds of copper. How much copper is contained in the bodies of 1,200 such people, or 1,200 people that are about 150 pounds each? I'm going to use a proportion here to solve, okay? So one person of this size, okay, their body contained 2.3 times 10 to the negative fourth pounds of copper. And so 1,200 such people, okay, would contain how much copper? So one person to 2.3 times 10 to the negative fourth is equal to 1,200 persons to how much copper? Now we can cross multiply to solve for x. X times 1 is x. Then we want to multiply our 2.3 times 10 to the negative fourth times 1,200. Now I'm going to write that 1,200 in scientific notation form as 1.2 times 10 to the third, simply because it's going to make it easier for us to perform the multiplication here, all right? Now we can rearrange these factors. You know, don't think we're foiling things. This is all multiplication. And we can multiply these numbers in whatever order we want. So I'm going to multiply 2.3 times 1.2. You can use your calculator there. That gives 2.76. And next I'm going to multiply 10 to the negative fourth times 10 to the third. And when we multiply like bases, we add those exponents, don't we? Negative 4 plus 3 is a negative 1. So that's a times 10 to the negative 1. And there we have our answer in scientific notation form. And we have determined an amount of copper, haven't we? Pounds of copper. So if you're asked to leave your answer in scientific notation form, you'd stop there. If by chance we're asked to write our answer in standard form, okay, then we're just going to take that decimal point and move it one place to the left and write this as a 0.276 pounds of copper. In example 2, we're given that the land area of California is approximately 1.6 times 10 to the fifth square miles. And the 2012 population of California was approximately 4 times 10 to the seventh people. And we're going to use this information to estimate the number of square miles per California resident. Okay, and that word per is a division word, and it tells us the order in which to divide these. Okay, we're going to divide square miles by the number of residents. Okay, so we're going to divide 1.6 times 10 to the fifth square miles by 4 times 10 to the seventh residents of California. And as we divide, okay, this is all multiplication, so we can kind of pick and choose how we divide things. As we divide 1.6 by 4, that quotient is 0.4. And as we divide these like bases, using our quotient rule, we'll subtract the exponents 5 minus 7. So we're going to write that as a 10 to the negative 2 power. Now, if we want to write this in its standard form without exponents, we move that decimal point 2 places to the left. Okay, so 1, 2, 4 times 10. Oops. We took care of that exponent, didn't we? So no times 10. So 0.004. And that's square miles, or you might say miles squared per person. And there we've got our answer in its standard form. Okay, but if we want to write this in scientific notation form, the 0.4 times 10 to the negative 2 is not the correct scientific notation form, because we want to see at least we want to see a unit here to the left of that decimal point, don't we? So in its equivalent scientific notation form, we would say that that is 4 times 10 to the negative third square miles per person. Again, because scientific notation has a digit to the left of our decimal point. All right, students, good luck on those problems involving scientific notation.